So let's look at equations of lines, or the linear function as it's known. We know all straight lines can be put in that form, y equals mx plus b. When it's written in that form, m is the slope, b is the y-intercept. Just like any polynomial, the constant is the y-intercept. Another way we tend to write it is in general form, where we make it all equal to 0. Now, when we do that, we tend to make sure a, b and c are integers or surds. Because obviously if one of the coefficients is root 3 or something like that, you can't make it an integer. So it's either a surd. In other words, we tend not to have fractions, I guess is what I'd say. I know there are some people who are paranoid and say a has to be positive. That's rubbish. There's no reason why. Why is A so important to be positive? Another one could be positive too. I will concede I tend to make it positive because I like to start with a positive number, but there is no necessity for it. Find the equation of line perpendicular to y equals 5x minus 2, and it passes through the point 0.6, and we want it in general form. Okay. Well, the slope that we want will be the negative inverse of the slope of this line because they're perpendicular. So the slope of this line is 5, therefore the one I want is negative a fifth. There's my slope. They've told me the y-intercept. So that makes putting it into y equals mx plus b form quite easy. Now all I've got to do is move everything to one side, multiply by 5, get rid of the fractions, and we have, oh, here we go. X plus 5y minus 30 equals 0. It's in general form. Okay. Now there are some special straight lines that don't conform to that y equals mx plus b situation. And they're ones that I say parallel to the x-axis. They'll always end up being y equals some constant number. There's one there. Let's say it goes through the point 32. What we know is every y value on that line must be 2 because it's horizontal. Hence the equation becomes y equals 2. Could you say that's in the form y equals mx plus b? I guess you could in that situation because the slope of that line would be 0. So you've got 0x plus the y-intercept. So in that case, yeah, it does conform. However, when we do ones parallel to the y-axis, it becomes a little bit differently now, because let's go through the same points. Now, every x value there must be the same, so we know it's x equals 3, but I don't know how we can say that conforms to y equals mx plus b. What's the y-intercept? Hasn't got one. What's the slope? It's infinite. Well, okay, if you think of infinity as 1 over 0, I suppose you could say y equals 1 over 0x plus a y-intercept, which we don't know what it is, but to get rid of the fraction, we'll multiply by 0. No, we still don't get x equals 3, do we? No, it's not going to work. Okay, that was a very quick one to start off with. Okay.